In this video, I am going to teach you FP growth algorithm in module 3 under data mining 18 CS 641. Yes, in the last class, in the last video, I have posted how to generate frequent item set using a priori algorithm. This is another technique. The FP growth algorithm is another technique to generate the frequent item set. Yes. So, what is the problem in a priori? Why we are going to FP growth algorithm is, here the time consumed is less because we have some reduced number of frequent item set. So, we have the reduced number of association rules with which we are going to generate a reduced frequent item set. So, here we'll be seeing that the time consumption is less to generate the frequent item set. Yes. So, we'll see what is FP growth algorithm. The algorithm is an improvement to the a priori method. As I said, a frequent pattern is generated without the need for candidate generation. As I said, here we are going to create the frequent pattern, that is association rule, that is frequent item set without the candidate generation. Here no need to generate all the candidates. In a priori we have generated all the possible candidate set, but in the FP growth algorithm we are not going to generate all the candidate set. Clear? That is why the time consumption is less compared to a priori in FP growth algorithm. FP growth algorithm represents the database in the form of a tree called a frequent pattern tree. So, we are also going to generate FP tree here. Yes. So, FP tree is a compressed representation of the item set database. Yes, the tree structure not only reserves the item set in database but also keeps track of the association between item sets. So, what we are going to do, we are going to represent the database in the form of the tree structure, and it also gives the idea of how every item is associated with the other items. The tree is constructed by taking each item set and mapping it to the path in the tree one at a time. So, how we are going to construct the tree is, so we will be taking each item set and we will be mapping it to the path in the tree one at a time. Yes, mine the tree recursively to get the frequent pattern. So, we are going to prune the tree recursively so that we will get finally the frequent pattern. So, with the frequent pattern, what we have to do is, the concatenating the frequent pattern generates the conditional FP tree. So, once the frequent pattern is done, we have to concatenate and to get the conditional FP trees. Yes. So, these are the steps to create for the FP algorithm to generate the FP tree. As scan database once, first we have to scan the transactions that occurred from the database. So, we have to check the frequent one item set. So, we have to take the count of the every one item set. Second step is sort frequent item in frequency descending order. So, that will be called as F list. So, according to the count, support count, we have to order or sort the items in the descending order. See, for the item A, if it is 7, and for the item B it is 6, the support count is 6, then we have to put in the descending order, that is AB. Okay, then the step is scan database again, construct FP tree algorithms and complexity. Again you have to scan once to construct tree algorithm, FP tree algorithm and its complexity, as we will see now with the example so that you can understand easily. Yes, see here. So, this is the transactions that is stored in the database. See here, this is the transaction that is stored in the database. These are the transaction IDs and these are the items which are bought together in the every transaction. So, if you take the transaction 100, here I1, I2 and I5 are bought together, and transaction 200, I2 and I4 are brought together. Like that we have few transactions here. So, with this we are going to generate the FP tree now. Okay. So, first what we have to do, the ultimate aim is we have to create the frequent item set. Clear? We have to find out the frequent item set. From that, the second step is we will be using the confident rule, we will be generating the association rule. So we have the two techniques to create the frequent item set. One is a priori and the second one is FP growth algorithm. Since the a priori generates all the candidates, it considers all the candidate sets to find the frequent item set. It is taking too much time, so we went for this FP growth algorithm. So ultimate aim is to find the frequent item set. Okay, so in order to find the frequent item set, first we have to go for we have to find the FP growth tree. So what we are going to do, what is the first step to calculate the FP growth tree is, as we said in the previous slide, the first step is to scan the database and count, like support count of every single data item, one item data set. So what I am doing, how many items do we have here? We have I1, I2, I3, I4 and I5. So only 5 items we have. So first step is create a tabular column listed with all the items. So I have 5 items. So I have listed I1, I2, I3, I4 and I5. Now as per the steps, as per the algorithm, FP growth algorithm, the first step is to count. So we have to take the support count. So how many times I1 are occurring in the transactions? So I1 1, 2, 3, 4, 5, 6. So 6 times I1 are occurring. So what I am doing, I am entering it as 6. Then what about item 2? That is 1, 2, 3, 4, 5, 6, 7. So I am writing it as 7. Then I3. I3, yes, 1, 2, 3, 4, 5, 6. So I am writing here as 6. Then I4, 2. Sorry, I4 will count 1, 2. Yes, 2. I5, 2. So I5, 1 and 2. Yes, so I have written here. Now in this, since we have come across, we have not come across this situation, I want to say one more thing here. That is, if we have called item number 6 and its support count is only 1, I'll be writing here I6 as 1. But what we have to do is, if the support count of any item is not satisfying the minimum threshold, minimum support threshold, then we should not consider that particular item. Clear? So what we have to do, we have to remove that item. We have to remove that item if the support count is 1. Since the support count of this example we have taken as 2, here the minimum threshold, minimum support threshold is 2. I am considering all the items here. If I have one more item called I6 and if its support count is 1, then I have to remove I6 from this tabular column since the support count is 1. Clear? Then what is the second step? The second step is to keep the items in the descending order based on sort the items in the descending order based on the support count. That's what we have seen as the second step in our FP growth algorithm. Yes. So what I am doing now is, see here. So what is the highest count here? I2. So I am keeping I2 here. Then comes I1, I3 and I1 and I3. So I1 and I3 I am making here, and I4 and I5 has the support count too. So I am mentioning here. Okay. So I have done with the second step. Okay. What is the third step? Now we have to create the FP tree. How can we do it? I'll show with the pencil. Okay. So we will start with the first transaction. What is the transaction 100? It is showing that I1, I2, I5. So what I have to do, I am going to start with the null. So I'll start with null. Okay. So I1, I2, I5. So I am writing as I1, I2. Since all are there in this tabular column, I am taking all. If, as I said, I6 is there and it has the support count of less than threshold support, then I have to omit those. Clear? So if I have I6 here, then what I should do? I should not consider this. I have to remove this and I have to list only those items which have the support count greater than the minimum support threshold. Okay. So for the transaction 100 I have done. Okay. What is the second transaction? I2, I4. So whether I have mentioned I4 here? No, only I1 is there, I2 is there, I5 is there. So I have to add I4. So with what this I4 is connected? With the I2. So I am connecting I4 with this. Also I have to write the count of every items. See, I1 is there. I1 is 6. So I1 6 I have to write here, and I2 is 7 and my I5 value is 2 here. So I am writing 2 here. Along with the item we have to write the support count also. So for the transaction 200 it is done. Then T300, it is I2, I3. So I3 is here